Heating and cooling systems play a vital role in modern life, with devices like heat pump and refrigerator being essential for maintaining comfortable living environments and preserving food. First, we talk about the heat pump. A heat pump is a device that transfers heat energy from a colder area to a warmer one by using chemical work. It can be used for both heating and cooling spaces by reversing its operation, making it an energy-efficient system for maintaining indoor comfort. Then, a refrigerator is an appliance that removes heat from its interior to keep food and other items cold. It operates by circulating a refrigerant through a cycle of evaporation and condensation, effectively lowering the temperature inside the compartment.
Now, you must be very interested about the theory behind the refrigerators and heat pumps. And I'm gonna start and show you what is the working principle of refrigerators. Refrigerators, just like heat engines, work in a cycle. This is a basic vapor compression refrigeration cycle. The working fluid inside the refrigeration cycle is called a refrigerant. The refrigerant enters the compressor as a vapor and is compressed to increase its pressure and temperature by consuming work. It then enters the condenser and condenses to a liquid and cools down. There is heat output since heat is rejected into the surroundings. It then enters an expansion device, which is used to reduce the pressure and temperature of the refrigerant in order to achieve a liquid-vapor mixture of desirable quantity at the exit of the expansion device. Now, it enters an evaporator where the refrigerant evaporates by absorbing heat in the refrigerated space. The refrigerant changes from a liquid to a vapor. It will then go back into the compressor as a vapor, and the cycle repeats. Here is a schematic for analyzing the energy conservation in a refrigerator. The main purpose of refrigerators is to remove heat from a heat sink. Therefore, we are interested in the amount of heat that can be removed. From the first law of thermodynamics, we know that the work done on the compressor is equals to the heat released from the condenser minus with the heat absorbed by the evaporator. The coefficient of performance of the refrigerator is a dimensionless ratio of desired output heat divided by the required work done, and the formula can be derived as shown as below. For the heat pumps, it absorbs heat from a heat sink and delivers heat to a heat source by consuming work. It uses the same vapor compression refrigeration cycle, and therefore, the schematic is the same also. But different from refrigerators, the main purpose of heat pumps is to add heat to a heat source, such as indoor space of a building, and we are only interested in the amount of heat that can be transferred from the condenser to the heat source. Hence, the coefficient of performance of the heat pumps use the same concept as before, but we change the desired output to the heat released from the condenser, and the formula is derived as below.
Heat pumps are used very widely for many purposes due to their viability. Thus, they have many practical applications. Firstly, heat pumps can be used as heaters or coolers. They heat up or cool down an enclosed space by transferring heat towards or away from the designated place. Typically, industrial heat pumps transfer more heat faster than commercial ones due to the sheer scale of industries being way larger than domestic ones. Next, a heat pump can surprisingly work as a dehumidifier. By cooling down and condensing very warm, wet air into liquid, the water content in said air decreases. This is usually done to protect items such as furniture or machinery in places where humid air is very common, such as countries in tropical climates. In addition, heat pumps can work to heat up water for commercial use. These heaters can either be a tank type or tankless type, in which the water is heated directly for use. Each purpose and situation would call for different heaters, hence the two types. Finally, another extremely common use of heat pumps is in refrigerators, in which they keep food fresh and edible. Most modern households, restaurants, and factories are sure to have at least one, due to the sheer importance of edible food in society.
Next will be the weakness and strength of heat pump. For the weakness of the heat pump, it is high initial installation cost, less effective in extremely cold climates, requires electricity to operate, and it may need backup systems in freezing temperatures. And lastly, it is weak in installation can be complex. For the strength of the heat pump, it is highly energy efficient. It can transfer 3 to 4 times and more energy than consumed. It has dual purpose, which is heating and cooling. And also it can reduce the energy bills. And sometimes it is environmental friendly because it is renewable energy such as air, water, or ground. It have a long lifespan from 15 to 20 years, and also it is low maintenance fee. So why heat pump is used so widely? This is firstly because of the government incentives and subsidies. Secondly, it is ideal for temperate climates. And also it aligns with renewable energy goals. It have long-term cost savings, justify initial expenses, and lastly, it reduce dependency on fossil fuels. However, it still have the environmental impact. Firstly, it will lower the carbon emissions than traditional heating systems. Secondly, it can be carbon neutral when powered by the renewable electricity. Thirdly, it also reduces the greenhouse gas emissions. And lastly, the heat pump will help the combat climate change. So here is two questions I would like to ask. For the first question, in a refrigerator, heat is transferred from a lower temperature medium, which is the refrigerated place, to a higher temperature one, which is the kitchen air. Is this a violation of the second law of thermodynamics? Explain. The second question, define the coefficient of performance of a heat pump in words. Can it be greater than unity? Answer for the first question, no, because the refrigerator consumes work to accomplish this task. For the second question, the answer is the coefficient of performance of a refrigerator represents the amount of heat removed from the refrigerator space for each unit of work supplied. It can be greater than unity.